All right, hello everyone. My name is Isaac Esquivel. I'm the agronomic and forage crop specialist at the University of Florida, based in the NFREC in Quincy.
I'm Scott Graham, extension entomologist at Auburn University and Alabama Extension. I'm in main campus in Auburn, but have responsibilities across the entire state of Alabama.
All right, we're going to be talking about what we learned and our experiences dealing with the Cotton Jassid this past 2025 season. All right, so what is the Cotton Jassid? So it's officially called the two-spot cotton leafhopper, also known as Cotton Jassid in its native range, and it's native to the Indian subcontinent, east to Japan, and micro Asia. Um, and it's slowly started to move elsewhere for the past 10-ish years or so. So we got Ivory Coast in 2023, Cameroon in 2023, Puerto Rico in 2023, and then of course Florida in 2024 into this 2025 season, and most recently Honduras, which was late August of 2025. Okay, so two-spot cotton leafhopper in the United States. So we'll start with in 2024, which is going to be on the right-hand side here. It was found in passive trapping samples put out by our Florida Department of Agriculture and Consumer Services in their trapping network. And it was mainly found in about 16 counties, mainly in South Florida, with one county in the Panhandle, that being Jackson County up in the top left portion of the Florida Panhandle. And it was found on not only in passive traps, but it's also found on plants in the field, on okra, hollyhock, cotton, hibiscus, wireweed, black nightshade, and eggplant. And then moving to 2025, and it kind of stayed active in South Florida since it was initially detected. But we first detected it in cotton in 2025 in Gilchrist County, Florida, the first week of July. And it was found in about 115 counties in the Southeast in about 4 weeks. So if we just look at the figures here going in the progression here. So as of August 8th, that was about 4 weeks after we first detected it in cotton. It was kind of spread out um, across Alabama, Georgia, South Carolina. 4 weeks after that, end of August, it was pretty much throughout the whole cotton growing belt region in the Southeast. And then by the end of the season, it was probably in every county that had cotton growing in Alabama, Georgia, South Carolina, Florida. And it's barely started getting into North Carolina in the late fall. And then end of season wise, spreading out from the southeast, it was detected elsewhere other than southeast. We have one detection in Mississippi or in Tennessee, also in Louisiana and Texas. But a few of these detections were on plants ultimately sent from Miami, Florida. Some hibiscus was sent over with jassids on them. Now let's talk about how do we identify cotton jassids. So they're very small. They look a lot like other leafhoppers, like the potato leafhopper, and they can be distinguished by a pair of two black dots on their head or their wings, which you can see the arrows pointing here to them. But if you want to get a really kind of confirmation ID, you do need to dissect the male genitalia for confirmation, or you need to do molecular identification. Early instars are nearly impossible to distinguish between other species, especially potato leafhopper. However, late instar nymphs, about fourth or fifth instar, have black dots on the developing wing pads. So you can see in this picture here in the bottom right-hand corner. Now, females lay eggs into plant tissues, whether it be on the petioles, on stems, or even the leaf surface itself. So you will not see them with the naked eye. The eggs hatch in about 3 to 4 days. And nymphal development, they have 5 instars, roughly takes about 10 days to go complete all 5 instars. And there's a range between 5 to 16 days, depending on temperature conditions and host plant that they are on. Adults live for about 15 days on average in cotton, or 12 to 37 days, depending on the host plant again. So that puts it off of a generation time of about 2 weeks between, say, egg and adulthood. They are highly polyphagous, we'll say selectively polyphagous. They have been confirmed to be reproductive on at least 25 species across 15 different plant families. However, they have a preference for malvaceous plants and asteraceous plants, mainly being cotton, eggplant, and okra, and then ornamental hibiscus. And these are just examples of reproductive hosts that we did observe in Florida this past season. We observed them on eggplant, this Caesar weed, Turk's cap, swamp hibiscus, Florida pulsea, pokeweed, and then soybean is the only one we did not find nymphs on, just adults feeding on soybeans this past season. Now, how do they feed? So they are piercing sucking insects and they feed on plant tissue. They generally feed on the lower surface of the leaf, and in the process of feeding, they introduce salivary toxins, which can be detrimental to the plant and cause hopper burn, which is characterized by yellowing, reddening, browning of the leaves, can lead to even complete desiccation of the plants in some cases, and also has effect of the leaves curling upwards, this upward cupping. But the important thing to know about hopper burn, although it is different depending on the host plant in cotton, plants go downhill rather quickly from the first signs of hopper burn until you get to desiccated looking leaves. So we can go back here looking at the initial stages here on the left-hand side, see some slight yellowing, and then go proceeding down stages of hopper burn development, see more yellowing in leaf margins, get a little bit of reddening there on the tips of that leaf in the center picture. Then as it progresses, you see some upward cupping here on the left-hand side. All of these are kind of cupped up. And then looking out into a field, you can see various degrees of hopper burn injury, a lot of red, yellows, and then upper leaf upwards cupping of the leaves. And then you can even see some of the drier foliage or desiccated foliage on the lower half of the canopy. And again, just looking more images of symptoms of hopper burn. So probably late stage symptoms where we see the leaves are looking pretty dry, desiccated. These haven't turned fully red yet, but on the right-hand side, you can see leaves that have already started to defoliate from hopper burn, as well as a lot of more reddening leaves. So just to give an example of how quick symptoms do develop, here on the left-hand side, Scott and I went out and put on an on-farm insecticide trial. We put it out on August 15th, went back 4 days later to do 4-day after application counts, and the field looked like this. So you see, when we sprayed it, you can definitely see hopper burn, but you saw some green foliage still. And then 4 days later, it went to completely red leaves and even pretty desiccated at that point. And that was only in a time period of 4 days. Now, we will note that the population in this field was extremely high. We were averaging about 30 jassids per leaf, but it's not just due to that high pressure. We even see the rate of change in hopper burn development in low pressure fields as well. Notice we came up with the hopper burn injury rating scale, very preliminary. Probably needs some adjustments, but just giving examples of different stages of hopper burn here. We starting here at 0, green plant. Our number 1 would be some slight yellowing at the outer margins. 2, we start seeing a little bit of cupping and yellowing more in the inner margins. And then at 3 stage, we start seeing the reds develop, getting to 4 where almost the entire leaf is red. And then 5 would be a dead or toasty leaf or a defoliated leaf.
Then Isaac, if we can go back to this one, from what we understand, right, somewhere between a 2 and a 3 is kind of the injury is going to happen, correct?
Yes, I think when it gets to 2 or 3, you can't stop it. And
Yeah.
I
So
don't think at all it will be able to stop it even at a 1.
yeah.
But yeah.
Well, all right. Well, let's talk about some of our preliminary observations with Cotton Jassid. Start that slide over. So. All right, let's talk about some of our preliminary observations with Cotton Jassid. We did a lot of work as a working group across the Southeast in Florida, Alabama, Georgia, South Carolina. A lot of research trials, a lot of observations, walking fields, evaluating materials just to see, what actually is this pest, what is it doing, and what do we need to do to mitigate issues. And so this is for us truly a new pest, such that we didn't even know how to scout for it when it first showed up. So we had to do some of that stuff. So Dr. Philip Roberts at Georgia went out and on August the 8th and started doing some counting. And the first thing to do is, where are these things on the plant? And so what he found, and it seemed to be true in all of our observations, is, at least for us this year, they tended to be in the upper portion of the cotton canopy. So he did some counts on the first leaf below, expanded main leaf below the terminal, the second, third, fourth, and fifth, and they really seem to be concentrated in the third, fourth, and fifth leaves below the main stem. And so our current scouting recommendations are to go for the fourth main stem leaf below the terminal, flip it over, and look for cotton jassids. Now, if you're a cotton scout or familiar with cotton at all, you know that's around that node where you're looking to make PGR management decisions. So that's a good way to be able to know if you're looking at the right leaf. But also, as long as you're targeting the fourth, if you're in the third or the fifth, you're still kind of in that hot zone where jassids may be. And we've also got kind of our different preliminary thresholds there. You see, we dropped them very rapidly, very quickly. I think, Isaac, our first threshold was actually 5 jassids per leaf, and that was never even mentioned. Based on what we saw, we realized that was too low. So in a little over a month, we went from 3 per leaf to 1 per leaf pretty quickly. And that just shows how devastating this insect can be if it's not caught in time and managed properly. Something else that we had, this is actually some of Isaac's data from the experiment station in Florida, where we had a group project looking at how planting date impacts bug pests, stink bugs and plant bugs. And Isaac was fortunate to get a pretty good population built up early in that test. And so he switched it from a bug test to a jassid test really quickly. And so we planted, he had cotton planted on April 23rd, May 6th, and May 29th. And this is showing, this little line graph here is showing the jassid populations per leaf throughout the season. And what you see is, in the early planting date, when the jassid showed up, the cotton was only really susceptible for 3 weeks. So it really was able to outrun most of the jassid issues. The early May planted cotton had higher pressure for a longer period of time, but still much less pressure and susceptible much longer than the late May planted cotton. And so that's one of our recommendations this year for farmers, is to consider planting earlier, try to get the crop in, get it going, and get as much season behind you before jassids show up. And this observation from Isaac's research trial is part of what's driving that recommendation for us. So something else that we saw in the literature from India was the impact of leaf pubescence or leaf hairiness on cotton jassid populations. And, obviously we don't have a lot of truly hairy varieties anymore for several different reasons. One being, in the lower southeast, silverleaf whiteflies, and that's a situation that can make whiteflies worse. But so Dr. Jeremy Green at Clemson went out and rated a variety trial and took the leaf hairiness scale from the different reps for these varieties, and just did counts in one rep and looked, and he saw on average about a 50% reduction in the total number of cotton jassids per leaf in semi-smooth cotton versus smooth cotton. So even just a little bit of hairiness on that leaf can really go a long way in helping us, have a plant that the jassids just don't thrive as well on. Now, will that matter once we get, if we have an entire field of semi-smooth cotton? We don't know. Maybe not. It's something, there's a lot to learn with this thing, but we have picked up on some stuff that's going to guide our research moving forward. So when we get a new pest, there's 3 questions that you have to address first off to figure out what you need to do. What does it matter? Does it not matter? The first is, how do you kill it? Very simple, right? You spray insecticides. Count back after a couple of days, see what killed them, what didn't kill them, and have check plots, obviously, so you can see if we did nothing, what would have happened. The next is to find out, does it matter? Does it limit yield? Does it actually cause economic loss in fields if left untreated? And then the third one is, when do you kill it? What are your thresholds? When should you be concerned about this insect? Unfortunately for us, and the manner this thing showed up, and primarily showed up in commercial fields, not on experiment stations, we were kind of having to fly by, not fly by the seat of our pants, but we were having to make some calls quickly without even knowing when this thing first showed up. We didn't know if it was going to reduce yield or not. We figured out pretty quickly, yeah, it probably is. But so we, normally you would do trials, you would look at different threshold timings, and then figure out which threshold you should use based on your yield at the end of the year. We didn't have that option this year. We had to answer question one, then question three, and then question two. And so we'll get into some of that now. So we looked at a lot of different insecticides, and we'll show some of that here in a couple of minutes. Some of it was replicated on farm. Some of it was small plots. Some of it was large plots on farm. Some stuff was done on experiment stations. But these were all done in Alabama, Florida, Georgia, and South Carolina in 2025. That says 2026. We found some options that actually provided pretty good control. For the most part, what was used in commercial fields this year was driven by availability and also price. And so, some of the insecticides that we found are a little bit on the more costly side than a lot of what we're using for plant bugs and stink bugs. But I think we've generated the data to show it's worth it to use those more expensive insecticides in those situations. But before we even get into talking about these different chemicals, the most critical thing is, this year we were just getting by, but in the future, we've got to think about insecticide resistance when we're spraying for cotton jassids. As Isaac already talked about, they have a very short life cycle. In 2 weeks, it goes from a nymph to a reproducing adult. And insects with fast life cycles are pretty good at developing resistance. And so this insect is resistant at some level to essentially every chemistry used in its native range. And so that means for us, we're going to need to be judicious with insecticides, and we're going to need to rotate modes of actions and chemistries to try to mitigate resistance as good as we can. Now, this is kind of a big view picture looking at some of the different insecticides that we tested across the Southeast this year. So this first slide is showing all the materials that we had at least 2 observations in. Some of them we had as many as 9 observations, but we had at least 2 in all of these, which gives us more than one data point to look at. This is also summarizing across rate ranges and sample dates. So we sampled anywhere from 3 to 14 days after we made our applications. And this is, again, just kind of a high level, big picture view at what consistently provided control and what didn't. And so we just kind of thinking about, that's a lot of stuff on this slide. What's the easiest way to look at it? And so we decided to pick a number. We went with 70%. So anything with 70% control or greater is in our green bars there. So those are our good, with our preliminary data, these are our good options. Anything in the orange bar is considered moderate control. That's 50 to 69, 70%. And then gray is less than 50%, not good. A couple of important things to point out here. One in particular is that bifenthrin or pyrethroids did not provide good control. That is, for a lot of farmers in the Southeast, a very commonly used insecticide, provides excellent control of stink bugs, provides good control of plant bugs in places where there's no resistance. So that's something we're used to spraying. But unfortunately for this pest, one person I talked to said that it looked like putting bifenthrin on cotton jassids was just fertilizer for them, just made them grow even quicker. And so obviously that's not true, but it kind of drives home the point of that pyrethroids are probably not going to be an option for this pest. Biodrin was probably one of the more commonly used insecticides this year. Again, that picks up plant bug and stink bug control as well. It's not the best option that we have, but it was very available and another product that we're used to using, used to paying for. But if you get into to trouble. If you've got big populations, products like Venom, Planazelin or Vortento, which is a new insecticide that should be labeled this year, Carbine, Savato, Courier, Safina provide very good control. So we have good options. We have options that should be available this year that this year provided very good control. So these same thing here. This is just looking at one observation. So we had it out in one test, and the Centric plus Lambda did Indigo did a pretty good job there. 74% control. These other products provided little to no control at all. So we're going to have to do a lot more research on this to figure out what truly is the best products. When should we use them? We considering other pests that might be in the field as well. How are we going to best control this insect? We also looked at rates, right? And so, do we need to use higher rates of these products? So for Biodrin, it's pretty obvious that, hey, a little bit higher rate provided better control. So we have in the orange bar there 6 ounce rate, and the blue bar is 8 ounce rate. And you see at 3, 7, and 14 days in 5 and 4 trials, significantly better control with the 8 ounce rate than the 6 ounce rate. Now, if you've got a threshold population, the 6 ounce rate might be enough to buy you some time. But if not, you need to go with the higher rate. With Carbine, we did not see that same rate response. Now, we've got fewer observations, only one with that lowest rate. But generally speaking, the 2 and the 2.5 ounce rates were pretty similar. And so, not always more is better. Sometimes you can get by with a little bit less. It just kind of depends on the product and the situation at hand. So then the next question is, when do you kill it? And so that's something that we've talked about. I've already shown all of our thresholds, how they changed and where it came out. But part of that was some research again that Isaac had there on the station in Florida, where he turned one of our tests into something else and tried to get some data. And so this is where Isaac turned into a threshold trial at the station there in Quincy. So this image was taken on August the 9th. This image was taken August the 22nd. And so he had two treatments there. One at 2, when he averaged 2 jassids per leaf, he made an application. And then what he called a prophylactic control, which was essentially the first time he saw one, he sprayed. And you see the untreated check there, a lot of the curling of the leaves, some of the yellowing on the leaf margin, and even some reddening starting to happen. A little bit more symptoms 4 days after the 2 per leaf application, but certainly much better than the check. And then his prophylactic control looks a little bit better than the 2 per leaf spray. So then he made another application. So this is on August the 29th. You can see is really going downhill quickly in his untreated plots there. This is 1 day after his second application on both the 2 per leaf and the prophylactic control. So those both triggered the same day. And you can see the cotton much greener. Looks a lot better than the untreated cotton for sure. And then now we're at 8 days after that second application on September the 5th. The untreated cotton is getting close to defoliating. It's about to start dropping leaves. The 2 sprayed plots look good. They're still green, maybe a little bit of yellowing starting to happen. Of course, we're getting later in the season, but certainly looks much better than the untreated check. And then the next week on the 15th, it's all but defoliated there, and his check plots and the threshold plots both look pretty good. Again, still holding leaves. We are starting to see a little bit more symptomology in those plots, so we're not eliminating the injury, but we are greatly reducing it, greatly slowing it down from just 2 applications, just 2 sprays. And then here we are at the end of the season on the 29th. Cotton starting to turn. Some of that might be jassid, but some of that's just the cotton's just naturally starting to get ready to open bowls and give up on the year. So, does it matter? Was this pest yield limiting in our research and plots that we had this year? Yes, it's the easy way to say it. So this is from that threshold trial that Isaac had. You don't need to be a professional entomologist or even a professional cotton person at all to look at the untreated cotton and then his two spray plots and see the difference that just two insecticide applications made on the amount of lint there in those images. When you look at it here, his prophylactic or aggressive control, a little bit more than the two per leaf, but both are significantly more, 142 pounds in his untreated check on average across all his replications. And so this was probably worst case. Well, I don't know if I'll say worst case scenario. This was the worst case that we saw in 2025. How about that? The Cotton Jassids showed up very early in the season. They sustained and persisted all season long. And if left untreated, they significantly reduce yield. But if we only made two sprays, which we can do, we preserved yield and made pretty good cotton. So here's another one that I think is a good image. So this was sent to Dr. Roberts at Georgia on September 22nd. So the week prior, something happened with the grower spray boom. They just missed a spray. Don't know what happened. Which when you're doing research, it's not always the worst thing, right? Get a little check plot out there and see what happens. So a consultant rode by and saw it, and he sent it to Dr. Roberts, and he said, "What do you think? I think that Jassid juice worked pretty well, right?" And so Philip said, "Well, hey, let's go out, flag it, mark it. Let's see if it matters at the end of the year. See if there's yield loss." So again, this is September 22nd. You can see some bowls opening on the edge of the field there. So this cotton is getting towards the end anyway. So did it matter? It did. You can see a different side of the road, but same image there. You can see that streak all the way down the field where they missed that application. It certainly did matter. On average, it was about a 30% yield loss in that strip compared to beside it where the insecticide application was made. So this is averaging everything that we have. Some of this is hand-picked. Some of this is machine-picked. But on average, across all these trials in the Southeast, we've got about a 28% yield loss from, in most instances, one insecticide application. For a lot of these, it was sprayed. We rated it for 2 weeks, and then the grower oversprayed the whole field. Go back and look, and you see on average about a 28% yield loss from again one insecticide application. So our observations early on in the year was that we could get a good 2 to 3 weeks out of a spray before they built back up to populations that needed to be treated. Now that changed as we got later into the season. A lot of cotton started being defoliated or just kind of started playing out, and the jassids started moving, and those sprays didn't hang on as long. So that we don't get 3 weeks of residual control, but we do if we knock them back. At least early season, we see about 3 weeks, 2 to 3 weeks before they build numbers back up behind that spray that cause symptomology and potential yield losses. But it's so important on this insect to be on time. If you're 5, 7, 10 days late, sometimes it means you shouldn't even spray. It's too late. We mentioned before when Isaac showed that slide with the rating scale. At a certain point, you just can't stop it. And so this image here, we sprayed with a very, very good insecticide. You see, we got essentially 100% control 7 days after our spray, but we were about 10 days too late on it. And didn't matter our check area or our spray area. It was almost totally defoliated when we got back in there. So timeliness is so critical for this insect. So this is going to be an evolving situation. There's still a lot of stuff we don't know. There's a lot of stuff we do know. There's some questions here. How long do we have to spray? When can we walk away? We don't fully know that yet, but we have some good ideas. What's next year going to be like? Again, we have no idea. It's pretty hard to predict insects. We are monitoring right now. We're recording this in early December. And there are still live cotton jassids in the field on plants right now. It's 34 degrees where I am in Auburn, and they're still here. So we don't know exactly how well they're going to survive the full winter, but we do guess that they're probably going to be in the system a lot earlier this year than they were last year. and that could cause problems for us. So with that, how's it going to impact seedling cotton? We don't really know. We did plant cotton in Georgia, Alabama, and South Carolina in September just to get some on it and see. And what we saw under hopefully unrealistic pressure doesn't look great, but under lower pressure, it's something that we will be able to manage. Maybe with an insecticide application, maybe not. We'll just have to see. So you see these images here from Tifton under very high pressure. This cotton is probably about 5 weeks old. You see where it's got an insecticide seed treatment and 4 foliar applications. It looks really good. Where it has no insecticide at all, it's nearly dead. But again, that's worst case scenario. What we're hoping for are more realistic scenarios. What we had in Prattville this year in Central Alabama, and you see our insecticide seed treatment only, no foliar spray, cotton spray with Biogen XP2, and then cotton spray with carbine. And those foliar sprays at 9 days after certainly look better, have less symptomology. They're not perfect, but they have less symptomology than our 9 day than our untreated check at 9 days. And so we're still looking to evaluate insecticides, see, if we need to spray thrips, how can we control both of those, jassids and thrips with one spray. So a lot of things we need to look at. It did look like in our observations that maybe in furrow, out of carb looks a little bit better in controlling jassids than just the imidacloprid seed treatment alone. That's something else that we need to just look into more and see, as we get more observations this spring of what does provide good control. So there are some other factors that will probably impact cotton jassid management for us in 2026. Soil fertility is a very important thing. Obviously, you have to provide the plant enough nutrients to maximize its yield potential. But if in a lot of cases, if you have too much nitrogen, really rank, highly growing plant, that attracts insects, and we think jassids will probably be the same. Something else that was in the literature and we picked up on in the U.S. as well is that plants that are deficient in potassium seem to crash a little bit quicker than plants with good potassium. And so that also plays into later in the season when you're starting to fill bowls and that potassium is moving out, it can crash quicker. But so make sure you're not over nitrogen, not over applying your nitrogen. But also make sure you've got enough potassium in the plant because that seems to be something to help fight it off. Planting date, again, we think earlier planted cotton is going to be at a lower risk than later planted cotton. So, as soon as you've got soil temps and moisture, I'm recommending in Alabama start planting. If that's, mid-April, get out there and start planting something and try to mitigate your risk of jassid infestations that way. And then the biggest thing is timeliness with your insecticides. Our threshold is one per leaf on average across the field. If it takes 10 to 14 days to get across everything that you have, you may consider going a little bit earlier than that because you got to get started sometime. And as we mentioned before, if we're 10 days late on a spray, sometimes that means no point in even spraying anyway. So timeliness is going to be so important. With that, I thought there was one more slide there. There's not. Is the only way to be on time is to have a scout. And so this is an insect in the lower southeast. We've kind of been able to get by without having, at least in Alabama, that many scouts in the field. But this insect really requires intense scouting, proper scouting identification to know that you do have cotton jassid and not another leafhopper. But also to be able to detect when it reaches treatable levels so you can make the most timely application possible to control that population. So with that, Isaac, we got a lot of people to thank, a lot of, not just our, commodity cotton commissions. Cotton Incorporated gave us a lot of funding to, in kind of a short time to help fight this thing, learn what we could. A lot of farmers that gave us fields that we could put tests out on, extension agents that are out there finding fields for us, working with growers to get stuff laid out. So this was a big team effort across the Southeast that took a lot of people. And I'm really proud of what we did, Isaac. I think we learned a lot. Still got a lot to learn, but I think we're in a good place for next year. We'd also like to thank Crop Protection Network for reaching out and asking us to put this webinar together. We hope it was beneficial. Hope you learned something. You can always reach out to Isaac or myself or Dr. Roberts or Dr. Green. We're always happy to help, especially with this Cotton Jassid deal, such a new thing. But again, really appreciate Crop Protection Network and putting this together so we can get this information out for everybody that needs it.